Well, hi, and welcome to the first chapter of the Psychology of Aging course. So let's get started. This hopefully will not be a super long lecture. I'm going to try to keep all of these lecture videos as brief as I can, and we will see how that works out. So the first chapter deals with physical aging and some of the changes happening physically, but before we get into the details of that, I think it would be good to start with a couple of bigger, kind of, I guess, bigger picture questions and ideas. Since we're talking about the psychology of aging, we need to talk about what aging is, and we need to talk about lifespan development. If you've had the developmental psych course, the lifespan course, um, and I think that might be a prereq for this course. I'm not 100% sure. You're surely familiar with some of the topics already, right? That course, being a lifespan course, covers aging, but of course it covers the whole lifespan. So it's worth mentioning the stages of life here at least, right? Going from childhood, and we can, maybe drill down and talk about differences between infancy and early childhood and middle childhoods and so forth. But for our purposes here, we'll just call it childhood, and then we'll move into adolescence, which is this transitional period of between childhood and adolescence marked by changes in physical growth, puberty, plus changes in the brain and issues related to maturity in that regard. And then once we enter into our adulthood years, this phase of life is called senescence. Senescence really is synonymous with the adulthood phase of life, but it also means aging. Something I always mention in the developmental psych course is that aging begins as soon as adolescence ends. Um, and that sounds kind of scary a little bit, but the critical issue here is that aging is a very slow process. It's a very slow, gradual kind of process. The changes that are happening are happening bit by bit, little by little, so that over the course of, say, when officially is this transition? At some point in your 20s, right? But early 20s, mid 20s, it's hard to say. There's no clear-cut distinction here. These stages or phases of life are at best approximations, but let's just call it some point in your early 20s that this is going to start happening. And but because the changes are so slow and gradual, over the course of 10 years' time, you will not really notice much, right? The changes will be so small that that you're not going to notice any really clear physical changes in appearance, or at least very minimal changes in appearance and ability and so forth. But because these changes gradually accumulate, then after 20 years' time, when you're in your 40s, some of the changes will definitely be more noticeable. And of course, again, after 30 years' time and 40 years' time, and so on, we're going to see more and more noticeable changes. Now, this idea of drilling down the phases into different spans is where we have to talk about the senescence adulthood phase of life, because in this course, we're not really going to talk too much about early adulthood or middle adulthood. We're really going to focus on late adulthood. That's the key theme here. But there are going to be points where we may need to mention a few things about the entire range of the adulthood years and talk about how some of the changes are happening throughout those years. But for the most part, we're going to try to keep everything focused on the later years. So again, of course, what's the transitional age between early to mid adulthood? When is middle adulthood? When does that transition to late adulthood? Again, there's no clear-cut, universally accepted answer to these kinds of questions. So we're not going to worry about those kinds of questions. It's not particularly useful, I don't think. Couple of other key terms I want to mention here, primary aging effects and secondary aging effects. So we see these age-related changes happening, and by that we mean changes that accompany age, right? As we get older, there are things happening to our bodies and to our brains and our cognitive abilities and so on and so forth. If it is referred to as a primary aging effect, what we're talking about here are things that are in fact caused by age. Our bodies age, the cells of our bodies age, our brains age, and that's going to cause changes, right? So those are called primary aging effect because whatever's happening is in fact caused by age in and of itself. But then there are also secondary aging effects, and these are also things that change with age, right? And they correlate with increasing age. But we use the term secondary here to say that they are secondary to aging, meaning that there's some other cause. And in this case, that might mean that there are certain health conditions that occur more frequently in older adults. And because these health conditions might have some degree of say, an impairment in maybe cognition, right? So one example could be Alzheimer's disease. So it is accompanied by declines in memory functioning. These losses of memory can occur sometimes in what we might call benign aging, right? Just the aging brain will have some memory impairment associated with it. So that's a primary aging effect. But once we see the more severe kind of impairment happening with Alzheimer's disease, that's something else, right? The memory problems are not caused by an aging brain, it's caused by the disease itself. But of course, because Alzheimer's disease is far more likely to occur in older adults than in younger adults, then these effects correlate with age. So we will call them secondary aging effects. As we go through the semester, we may have cause to mention whether or not something is primary or secondary. It's not going to be a huge focus, but we'll cover that here and there. Finally, it's worth noting here that when we talk about aging, especially the psychology of aging, we are not just going to have to limit ourselves to talking about psychological topics. We're going to mention here, for example, physical health and appearance, right? First one on the list and the major topic of our first chapter. But this can be relevant in a variety of ways because once we start getting into other topics related to our self-concept, self-esteem, and quality of life, all of these things can be impacted by our abilities and maybe changes or losses in our ability or changes in our appearance that we may not like. We may not like the fact that we don't look as good or as young as we used to. And that could certainly affect our social environment and our social behavior and our self-esteem and self-concept and so on and so forth. So these will all be relevant to psychology. Same goes for some of the musculoskeletal stuff, right? We're going to see a loss of strength, a loss of motor skill and coordination, and that might mean that certain activities that we used to perform, maybe leisure activities like sports or fishing or hiking or gardening, suddenly become no longer possible, or at least not in the same way. And so again, that affects our quality of life. Activities of daily living, we'll cover those at the end of the notes as being something of pretty critical importance here. And as we go through the whole semester, we're going to talk about perception, cognition, the social and personal part of ourselves, right? Our social lives, our personality, and ultimately mental health concerns with aging. Let's move into some of the physical side of aging. We're going to start here with the causes of aging, and we're going to keep it fairly simple here, but mainly we're going to focus here first on cellular changes. So there's two types of cellular changes worth talking about. The first is called oxidative stress. So what's happening is there are molecules in the body called free radicals. More technically, they are called reactive oxygen species. And so what are they doing here? They are oxidizing cells in our body. One good way to think about what oxidation means here, oxidation happens when, for example, you burn something, right? So if you're burning and making a fire, in a fire pit, what you're doing to the wood is you're oxidizing it. And that's a bit of an extreme example, but maybe a slightly more apt example is rust, right? So when iron is exposed to oxygen, it will eventually rust, and this causes a gradual slight degradation in whatever material that we are using that's made of iron, right? It might be a tool or something that's made of iron, and it gradually becomes less useful because of the rust and the damage and corrosion that's happening to it. And that's maybe a slightly more, apt way, like I said, to describe what's happening to our cells is, I don't want to say that they are rusting in any literal sense, but in a vaguely metaphorical sense, sure, why not? Let's go with that. Free radicals are always present in our bodies, and they can cause this kind of oxidation to cells. But normally we also have what we would call antioxidants in our bodies as well, right? And these are compounds that then eliminate these free radicals and prevent this kind of oxidation that's happening. But there are many situations that may cause free radicals to increase their numbers and or antioxidants to decrease their numbers. And this is what then results in oxidative stress, this imbalance between those two things. And I've listed here some of those factors, right? So a lot of it can be environmental in nature. So exposure to pollution, smoking, tobacco use, exposure to ultraviolet light. That's, sunlight without wearing good SPF level um, uh, exposure protection there. I lost the words for sunblock for a second. Um, and maybe diet, maybe stress, right? And all of these things can increase the free radicals in our bodies and decrease antioxidants. This is also why, for example, you'll hear a lot of medical professionals recommending a diet that is high in antioxidants. Oftentimes that correlates with the Mediterranean diet. And it's sometimes often described as not just a healthy diet that can prevent oxidation, which can be related to cancer in some cases, but it's also sometimes defined as as an anti-aging diet because we're minimizing the kind of oxidation that we're talking about here. So ultimately, when these cells become damaged, I got kind of a little bit of an image here at the top that's showing what's going on there. Eventually, the cells die. And once certain, all of the tissues in our body are made of different kinds of cells. We've got muscle tissue and bone tissue and organ tissue of various types. And as cells in those different systems and tissues start to die off, the tissues themselves lose their functionality. They lose their integrity. If it's part of an organ system, then that means organ function may start to decline gradually over time as well. So a lot of age-related changes are happening to the organs and tissues of the body as a result of this sort of stuff. Another thing that happens in terms of cellular damage refers to the telomere shortening I've got described here at the bottom. So what we're looking at here are some chromosomes, right? These X-shaped figures are chromosomes that contain all of the DNA sequences. Many of the cells, not all of them, but most of the cells in our body need to reproduce. They need to divide and replicate and copy themselves multiple times over the course of our lives. What's happening here is that the tips of these chromosome segments, that's the little yellow tips there at the end, those are called telomeres. The classic analogy you want to use here are the little plastic tips. What are they called? Aglets. I can remember that, but not sunblock. Um, um, wrap around the end of the chromosomes and prevent them from fraying, right? Prevents damage to the chromosomes. And what happens is that when cells divide, the chromosomes have to copy themselves and make a new copy that makes it into the new cells that are created from the original cell. And this happens over and over and over again as cells divide and divide and divide. And when these chromosomes have to divide themselves over and over again, gradually what happens is that the telomeres get shorter. And at one point, they hit a threshold where the telomere is so short that the chromosome is damaged and it can no longer make copies of itself. So when the cells can no longer copy themselves, they stop reproducing. And when they stop reproducing, what happens? Well, they just die. And so again, we're going to end up just like with oxidative stress, we're going to end up with some acceleration of cell death that affects tissue integrity and organ function. So more aging here. Now, besides some of the environmental stuff that I listed under oxidative stress, let's maybe mention a few other things that might contribute to aging. In some degree, there's just genetic issues, right? Some people live longer than others, but we're not necessarily just talking about total lifespan here in terms of whether you live to be 60, 80, or 100 years old, though that's relevant. But part of the concern is that for people who live to be 75, let's just say, some people are very frail and have shown a lot of large age-related changes that are happening to them, whereas another 75-year-old might be comparably very hardy and active and able. So in these situations, there's quite a bit of individual differences there. Some of this can, of course, like I described previously, be a function of environmental exposure related issues and dietary issues and overall health issues and so forth. But sometimes it may simply just be genetics. And this is not entirely and well completely understood. One thing I have listed here are these things called longevity gene networks. And what we're seeing here is a little bit of evidence that there are many networks of genes, that is, groups of genes that interact with each other. And these predict some aging effects that we can, just list here. Now, I mentioned a little bit about stress, I think, on the previous thing with oxidative stress. That can also just be caused by stress, right? So when we experience psychological stress, this causes some disruption of hormones in our body, and this alteration of hormones is going to affect inflammatory processes and functioning of the immune system. There's a whole field called psychoneuroimmunology that investigates this, and we'll have time much later in the semester to get into the details on that. But for now, we would just want to mention that that would suggest that stress can also cause these kinds of genetic changes and maybe some oxidative stress as well as a result of these inflammatory processes that it might trigger. But I want to mention epigenetics here as well. So what we're talking about with epigenetics refers to gene-environment interactions. And so we listed these environmental factors. I just described a little bit about genetic factors, but it's important to realize they interact with each other. And what's going on here is that different kinds of cells in the body, they all have the same genes, right? We have the same chromosomes in every cell of our body. But and those chromosomes and those gene sequences play an important role in telling those cells what to do, right? How to function as say, a cell within the pancreas or as a cell within the liver or as a neuron in the brain. And so you might think, isn't it a little bit weird and difficult to imagine how all of the cells genetically being identical can still have different functions? Well, that's because during the process of development, primarily or prenatal development and infancy, these cells undergo epigenetic changes. And what this means is that even though they have the same genes, there are processes referred to here as methylation. And what's going on is that methyl groups are these chemical tags that wrap themselves around the gene sequences. And by wrapping themselves around certain gene sequences, they're essentially blocking those genes from having any influence on the cell's activity. So when messenger RNA comes along and it reads certain sections of DNA so that it can then go do things in the cell to manufacture proteins and other things that are important for cellular metabolism, some of those gene sequences will get ignored because of these methyl groups that are covering up certain gene sequences. So there are different patterns of methylation across different kinds of cells, but this kind of methylation process can happen over the course of our lifespan, and sometimes altered methylation can start to really disrupt cellular function. And again, it's going to cause some cellular damage. And stress can disrupt this. And so this is where, again, I want to mention the importance of stress causing cellular damage. On the topic of secondary aging effects, I mentioned Alzheimer's disease earlier as a disease that we're going to see more often in older adults, and it's going to contribute to some age-related changes. But there are many diseases that obviously, again, can occur to people all across the lifespan. But what we're going to see, especially with what we want to focus on here, is a chronic illness are diseases that maybe because you have them for a long period of time will gradually lead to an accumulation of illness-related effects here. So we might think of cardiovascular disease, right? What happens with cardiovascular disease is that we start forming these arterial plaques in the arteries. Initially, this may not cause any significant change in our health, except maybe slight elevations in blood pressure. But over time, this increases our risk of a heart attack. If we have a heart attack, there might be some damage to the heart. We survive the heart attack, but following that, our overall cardiovascular fitness is just not what it once was, and it may not return. to what it once was. So that means there's now a change to some of our physical ability. We might also see this with congestive heart failure, that again, the heart just gets weaker because of high blood pressure and thickening of the heart walls and so forth. And then this results in, again, a significant decline in someone's physical ability and stamina. The side effects of cancer and its treatments certainly can take a toll on the body. And of course, that can happen all across the lifespan. But the older we get, the greater our risk of getting cancer is. In fact, when we start thinking about causes of mortality across the lifespan, in our early adulthood years, the number one causes of mortality tend to not be cardiovascular disease and cancer. But past a certain age, some point in middle age and beyond, these two things jump right to the top of the list. So our risk of these health problems increases quite a bit the older we get. I list osteoarthritis here mainly because the book tends to make a big deal about it, so we can mention. But the idea is, so it's going to happen to some people, but not necessarily everyone. Um, and the idea is that we're going to get some inflammation and stiffening of the joints, and that's going to affect mobility, quality of life, and pain as well. Uh, on the topic of Alzheimer's disease, there's of course a longer list of neurodegenerative conditions like, say, Parkinson's disease as well, Lewy body dementia, and so on and so forth. So we'll have some more to cover about the brain later on and cognitive impairments later on, but I'll just list them there. And then there's any number of other kinds of chronic diseases. The textbook mentions rheumatoid arthritis. Rheumatoid arthritis is an autoimmune disorder in which the immune system attacks the connective tissues of the joints. But there's any number of autoimmune disorders where the immune system attacks different kinds of bodily systems. There's systemic lupus, Sjogren's syndrome, inflammatory bowel diseases like Crohn's disease and ulcerative colitis. Multiple sclerosis is when the immune system attacks the myelin sheath of nerves in the body. Um, there's evidence of uh, autoimmune involvement in, say, type 2 diabetes, or is it type 1? Don't quote me on that. It's one of those two, and don't worry about that. And maybe even in some of the neurodegenerative conditions like Alzheimer's, we can have some autoimmune implications here. And the effects of these kinds of diseases are not really curable, but they are manageable by taking medications that suppress the immune system. But one of the side effects here is that these immunosuppressants increase our risk of getting ill, getting sick, getting other kinds of cancers. So there are an accumulation of health-related complications over time with these kinds of chronic diseases. All right, now on to the topic of the main theme of chapter 1 in the book is changes in physical appearance here. And what we have here first is our skin. So there are two key proteins in the skin, collagen and elastin. The role of these proteins is to make the skin flexible and firm and bouncy, right? And so we have many, why does our skin need to be flexible? Well, our bodies can move, right? I have joints that bend. And when a joint bends, the skin on one side of the joint will stretch to accommodate this, right? It has to get a little longer. But then just making a fist, right, as one example. So when I make a fist, the skin on the back of my hand has to stretch to accommodate the stretching of the skin around the back of the hand. And then as I extend my fingers, the skin would then stretch back or spring back to a shorter length, right? So what happens is that as we lose collagen and elastin and we lose that elasticity in the skin, that means it stays in a more stretched out state. It doesn't spring back to a shorter state. That means then that wrinkles and folds in the skin will be more apparent, say in this case when my fingers are extended, than when the fist is made, right? And so in all of the moving parts of our bodies, we're going to see maybe an increased likelihood of seeing the wrinkles and folds appearing. And that can happen on the back of your hands or around other joints, very commonly on the face because people get what are called smile lines around their mouth because the mouth, of course, does a lot of moving, and also little crinkles around the eyelids as well because our eyes move a lot as well. So again, there's a lot of declines there. The skin gets a little thinner as well. This diagram that I've got on here shows a little bit of that. It shows these collagen and elastin fibers in young skin and in this kind of a schematic diagram. It also shows fibroblasts there. These are the cells that actually synthesize collagen and elastin. And so what's the culprit here is that we're seeing a decline in fibroblasts, which means less of these proteins get made, and then the skin becomes thicker. We start to see the pockets and folds begin to appear where there's less collagen and elastin to hold it together and give it that firmness. And then the wrinkles get deeper as we age. We have the simulation here of a person showing these age-related changes in their skin of their face. Hair loss is another thing to occur. It occurs differently between the sexes. So I have the two scales here. For males, we have the Norwood scale that depicts male pattern baldness. And for what females, we have the Ludwig scale here that detects what we might call female pattern baldness. Um, so let's start with the guys over here. We're starting here, moving into the scale here, stages 1 and 2, a very slight receding of the hairline, typically more towards the sides, right? And then that advances a little bit until you start to see that bald patch appear more towards the back of the head, right? And of course, now they gradually expand and connect with each other so that then more of the entire top of the head becomes exposed with just some remnant of hair more towards the sides. For females, it's a little bit different. We start to see a widening of the part on the top of the head. And what's not so easy to see here, and this is, you can kind of see it maybe in the type 2 row here, is that there's also a lot of what's called diffuse thinning. So what's happening is that it's not just one patch that occurs right there in the center where the part is, and then it just spreads and gets wider. But all throughout the rest of the scalp, there's a lot of thinning of the hair happening there as well. And so more scalp is visible between the hairs, especially as you can kind of get a sense of that in the type 2 row. Skipped over the gray hairline, but the idea is that again, losses of cells that produce the pigment for the hair that gives hair its color. And with that decline, we're going to just see the gradual onset of gray hair, right? People may get their first gray hair at some point over the age of 30. Who knows? Again, a lot of genetic factors here. And then it just gradually accumulates from there. Height and weight changes as we age as well. So we tend to get shorter as we age. Two key reasons for this. One is, but they're both related to each other. It's a musculoskeletal issue, right? So our bones get less dense, and this is called osteopenia, right? As our bones just start to lose a little bit of density, um, and that means they can get shorter. Our spine gets a little compressed. And it causes a little bit of a postural change where people may hunch over a little bit, although that's really going to be more pronounced when we get to osteoporosis. So what's happening here is that osteopenia is a gradual decline in bone density as we get older. But once we hit a particular cutoff point where that density gets into a pathological range, a much more dangerous range where the bones are at greater risk of breaking should we fall, that's when we talk about osteoporosis. And it's very common to see people with osteoporosis who really kind of their posture is noticeably different, where the shoulders droop forward and they get a hunch on the upper back and they lean forward a little bit. What's also relevant here is that we also lose muscle fibers as we get older. This is called sarcopenia. And with that decline in muscle fibers, that means we have a decline in muscle strength, and that's going to affect our posture as well. So again, because of that change of our posture, our total standing height will be reduced a bit. Weight tends to change across the lifespan. Here we see these U-shaped curves, inverted U-shaped curves, where weight tends to peak. We gain weight, right? And throughout our early to mid-adulthood years, peaking somewhere in the 50s, and then it starts to drop off afterwards, right? And people start to lose weight um, as they get older. What's going on here? Well, it's a classic example of a multifactorial thing, right? So there's a lot of metabolic changes happening here. Some of it can be due to sarcopenia, actually. So what's happening is not only do we weigh less because we have smaller muscle fibers, or fewer muscle fibers and smaller overall muscles, but that means that the metabolic demand of our muscles will start to decline. And that's going to reduce the metabolic needs of the body, make us feel less hungry, so we eat less. Um, Might also be the case that the brain function starts to decline a little bit and its metabolic demand might be reduced as well. So again, that reduces our feelings of hunger and we eat less. For psychosocial factors, there may be things related to changes in our social lives that influence when and how often we eat, and when and how often we do other things that might be associated with weight gain, like alcohol consumption. If people are social drinkers, for example, and they go out with friends and do a lot of that throughout their adulthood years, they may gain weight as a result of that. But then they may choose to not do this anymore, right? Past a certain age, they maybe they stay home more often, and then they end up drinking less often, and that results in maybe some weight loss, right? So there could be a variety of social issues and social factors that influence our diet, and that's going to affect it. And also, it could mention health issues as well because of cancer, because of other kinds of health concerns. People's appetite may decrease. They may have some dental concerns that makes it difficult to eat or it's painful to chew. So that also affects their eating, right? So there's really a lot of things that we could dive into here that we don't really necessarily need to. All right, so as I previewed at the beginning of this here, we're interested in quality of life. And so one of the things to think about here is that the main theme when we talk about aging, the main goal of aging research is certainly we want to understand aging, but one of the main reasons for that is we want to improve the quality of lives of older adults. And that's going to focus then on what we refer to as ADLs, right, which is short for activities of daily living. I have a few key ADLs listed here. These are things that people expect to be able to do for themselves and to have a sense of independence, functional independence. We all feel that we should be able to do these things for ourselves. But quite unfortunately, for many people as they get older, they simply cannot do these things for themselves anymore, and they may need assistance. We need to understand the factors that influence this. How can we predict it? How can we maybe delay the onset of these kinds of concerns? Can we restore some of it, right? What kinds of physical or occupational therapy maybe can be done to restore some of these ADLs? Slightly more high level are what are called instrumental ADLs. These are more practical, sometimes maybe somewhat culturally specific kinds of things that we may need to do for ourselves, right? So being able to drive and maintain that kind of independence and not having to give up driving, that might cause you to lose a lot of self-esteem and feelings of freedom and independence. It makes life just difficult in many cities that are not particularly walkable. Uh, but even when it comes to using other forms of transportation, right? If you live in a city that does have public transportation, but you find it increasingly more and more difficult to access a bus or a train or subway, then that becomes, of course, a challenge as well. Preparing your own food separate from eating for yourself, right? Actually cooking and doing things in the kitchen. Um, Older adults may need to take more medications. That gets complicated. You have to remember to take all of the different medications and when you have to take them. You may have to remember to even get them refilled on time so that you don't run out. Money problems, keeping track of the money in your bank and not overspending or mismanaging things, forgetting to pay bills, being able to effectively communicate with other people, and having good social support and good friendships and other social connections is going to be pretty important. We're going to see as we get into that chapter on social and personality related topics, that's going to be pretty important. So when we think about overall quality of life, ADLs and IADLs are going to be very, very important. They predict quality of life. But there's also the concern of morbidity, right? So morbidity refers to a couple of things here. One, of course, is just lifespan and risk of dying. But there's also the issue of what we might call suffering, right? So as we get into our older years, we get to a point where we can't do it, a lot of these things, we lose the ADLs. And that's when we're in a more of a morbid state, right? We can't really be a functional, independent person anymore. And we don't like to be in those situations. So the book uses a phrase called compression of morbidity, and this refers to the idea that what we're trying want to achieve here is having people spend more of their adulthood years functionally independent, capable of their ADLs and IADLs. and not entering into those more suffering and frail years of their life, at least not until the very, very end, perhaps, right? So we want to compress that stage of life. We want to shrink it. And of course, that means, as I had already mentioned, understanding what factors, what psychological and ability factors contribute to ADLs. How can we predict and measure and track this change in people as they get older and maybe restore function in some cases as well. All right, I believe that is that, right? So that is the end of this particular chapter. So stay tuned for the next one.